In this video, we're going to talk about matrix operations. What is a matrix and what are some of the things you can do with matrices? And if you've never heard about the word matrix in a math context, then we're going to talk about it here. If you've heard the word matrix before, it may be from the movie, which is why I have the background here, the little picture of the matrix. And if you have not watched any of the movies, then I encourage you to go watch them. They're very fun. So a matrix is an arrangement described by rows and columns. So a table, right? We hopefully have seen data organized in columns, the up and downs, and rows, which are the left to right. So here we have some data. In this data, it's about the average weight by age for each gender, So man, in average, weigh about 188 between the ages of 20 through 29. Women weighed 156, and so on, right? You can see how this is organized. You can say, what's the average weight for ages between 50 and 59 for women? So women, and ages 50 and 59, you would say 172, right? So there's a organized way for you to figure out a value or just talk about a full category altogether. Like what about ages 70 and up? Well, you just say those are the two values for men and women, and so on, right? So those 12 numbers that are arranged into 2 rows and 6 columns, it can be seen or understood as a matrix, right? This is an example of a matrix. It's not quite the matrix that you're going to know it as, but it's the beginning of, right? This is how we start developing what is a matrix. Another example of what a matrix is, it's called Augmented Matrix, and it comes from linear equations. So a matrix can be a shorthand way of writing systems of equations. So for those of you that don't remember what a system of equations is, it's something like this, right? A number times x plus or minus a number times y equals some constant. And of course, it doesn't have to be x and y, it can be any other variable. So if you remember this, it was from solving systems of linear equations. So this is one equation, this is another equation, and there could be many different equations, but there can also be many variables. So this is the system of linear equations, and you can rewrite this as a matrix, or what it's known as an augmented matrix, right here on the right side. So you just put the coefficients, A1, B1, and then whatever it equals to. And we put this little bar here to separate the left side of the equal sign with the right side of the equal sign. So it went from a system of linear equations to an augmented matrix. So here is a more real example. 3 equations, 3 unknowns. So first equation is 3x plus y plus 2 times z equals 31. So that's, equation 1. So the augmented matrix, or the first row, would be 3, 1, 2, 31. So 3, 1, 2 are the coefficients in front of each variable. So 3, 1, 2, and then whatever it equals to. So the full purpose of this is to do other operations within the matrix to be able to get the value of z, y, and X if it does exist. We're not going to get too much in depth into that. So let's talk about matrix notation. So matrices can be represented in several different ways, right? So a capital letter, such as A, B, M, N, whatever, right? It has to be a capital letter, and that gives it the name of the matrix. So you can refer to a matrix as matrix A, matrix B, M, or N. Another way of representing a matrix is a lowercase letter in square brackets. So matrix A is the same thing as this lowercase letter with two numbers as suffixes, and that tells you the size of the matrix, right? And it is inside of this square bracket telling you that it's a matrix of whatever size. That's another way of representing a matrix. The size of a matrix is also known as the order of the matrix. So what is the order of a matrix? It's exactly that, how big this matrix is. How many rows by how many columns. So it's important for us to differentiate between columns and rows, like learn what is a row and learn what is a column. If you don't know, then that's one place to start. So if the values M and N are the same, like if the same number of rows, well, if the number of rows is equal to the number of columns, then that is what it's known as a square matrix, right? You realize that it has the same amount of rows as the same amount of columns. That's going to give you square matrix. Okay, so let's do an example here, and we're looking for information about matrix A. So what is the order of matrix A, or what is the order of A? So matrix A has two rows, so it would be 2 by 3. So this doesn't say 2 times 3, this is the dimensions of it. So we say 2 by 3. So matrix A, it's a 2 by 3 matrix. Okay? Part B, we want to identify this element. So what differs this notation from the previous one with the brackets around it is that this has no brackets, obviously. So this is referring to a specific element from the matrix A. So if you go to the matrix A here, perfect, and go to element row 2, column 3, so row 1, row 2, column 3, 1, 2, 3. So we can say that element A23 is element -1/5. And the other one, we have element 1, 2. It's going to be row 1, column 2. So that comes out to be the number 2. All right. All right, so let's talk about something called equality of matrices. So as it sounds, you're trying to determine whether two matrices are the same. So two matrices, A and B, are equal if and only if they have the same order and they have the same corresponding elements. So, for example, A is 1, 2, 3, 4, 5, and 6. So if we look at this and we say, it's A equals to B. And, the dimensions of A, it's 3 rows by 2 columns. So it's a 3 by 2. B, it's a 3 by 2 as well. So that works out. Can we just say that they're equal since they have the same order? No, that would be too rushed. We have to compare each element. So, 1, 1, they have the same value. 1, 2, they have the same value. Then we have 2, 1, which is second row, first column. They have the same value. So if you compare space by space, they're all the same. So yes, they are equal. What about A and C? Are they equal? And we check again the dimensions. Yes, they have the same dimensions. They really have the same elements within them, right? With the numbers 1 through 6. That's good enough, right? We can just say that they're the same and move on. But we would be wrong, right? Although the first element matches, that's great. If you check everything else, other than the 6's, nothing else matches, right? Here the 2, which is the element 1, 2, doesn't match with the element 1, 2 in matrix C. So those two do not equal each other, right? They're not equal matrices, even though they have the same dimensions, and they really do have the same elements in them. They're just not in the right order. Okay, so now let's talk about the real thing, which is operations using matrices. So as it sounds, right, we only have a couple operations in math, which is adding, subtracting, multiplying, and dividing. So here, you want to have a matrix A and a matrix B, and they're going to be of order m and n, meaning that they both have to be of the same order. And addition just goes as follows. Matrix A plus matrix B is the same thing about adding the corresponding elements from each matrix. So if we have matrix A be here 1, -2, 3, 6, and matrix B is going to be -2, 0, 4, 5, and if I add the two together, I'm going to get a matrix as the answer. Now, the elements of those matrix is going to be the sum between A and B at the corresponding spots. So here I already kind of have it pre-written, but not finalized. So what's 1 plus -2 is what I have here. So that becomes -1. Then we have -2 plus 0. Well, that stays -2. Then we have 3 plus 4, which is 7. And then we have 6 plus 5, which is 11. So we started out with two matrices that were 2 by 2s, or at least they had matching dimensions, right? Matching order. The solution is going to be of that same order. So if you don't get the same order, then you did something wrong and it's time to go back and double check. Okay. Subtraction, it is just like addition, right? They both have to be of the same order, and you're performing the subtraction between the corresponding elements, right? So here will be 1 minus negative 2, which is what I have here. So let's go ahead and finalize that. 1 minus negative 2 becomes 1 plus 2, which is 3. Then we have negative 2 minus 0, well, stays negative 2. 3 minus 4, negative 1. And then 6 minus 5, positive 1. Okay, so what if they are of different orders? Can we still perform the addition or subtraction? And so the short answer is that it's not possible, right? Because like here, for example, you do 1 plus 1, 2 plus 3, 3 plus 2, 4 plus negative 5. You don't have enough elements in A to add to the last row in matrix B, right? So that sum between the two elements is going to be undefined, right? It just cannot be carried out. Next, let's talk about scalar multiplication. And so, what is scalar multiplication? And so, whenever you have a matrix that is of order 1 by 1, for example, this matrix, right, the matrix with the element 3, as you can see, it only contains one entry, right? So how do we differentiate that from a number by itself, right? So the number 3 by itself, not inside of brackets, is known as a scalar. This right here is the matrix with one element, which is 3. Okay? So how do we do scalar multiplication? Well, it's pretty straightforward. If you think about it, remember that this is almost like one equation by itself. Each row, it's almost like its own thing. So when you do scalar multiplication, all you're doing is distributing or enlarging that matrix by this factor, right? So that number outside is known as this scalar, and of course this right here is known as the matrix. So 3 times each element inside of the matrix, like we're seeing here on the right side, and then we just simplify. 3 times negative 2, 6, negative 6, 3 times 5, 3 times 1, and 3 times 0. So it's pretty straightforward. The only difference is that you have to understand that this is a scalar and not a matrix, right? Okay. So next, what if we look at matrices and somewhat of an algebra perspective where you're just solving for x, right? For example, so here we have this equation, 2x plus a equals b. So how do we do this? You know, this is not just plugging in numbers and solving easily. So, well, it is easy, but it's not as straightforward as we are accustomed to it. So we are given a and b, but we don't have to plug them in. That's not ideal at the beginning. What we want to do is solve for x. But we want to keep in mind that when we're doing matrices, or matrix algebra, if you will, you want to only stick to addition, subtraction, and multiplication. Don't do addition. It doesn't work as we are used to. Okay? So stick to adding, subtracting, and multiplying. So I can subtract a from both sides, and I have 2x equals to b minus a. Then how can I get rid of that 2 that is attached to the x? Well, multiply both sides by the reciprocal, 1/2. Then I'm left with x is equals to 1/2 b minus a. Okay, so x is equals to 1/2 and of course if you cannot do the subtraction because of different size, then we would just consider this undefined or has no solution, right? Because it cannot be performed. Then we have 6 minus 1 is going to be -7. 5 minus -5 becomes +10. Then there's 9 minus 0, which is 9. And there's 1 minus 2, which is -1. And you can see matrices being represented in different ways. Like it could be a square bracket or like a big parentheses like this. And that works okay. That should be fine as long as you understand that what you have here inside of the parentheses is a matrix. Okay, so this is equals to -7 over 2. This becomes 9 over 2. 10 over 2 is 5. And then -1/2. Now, to really complete this, to really finalize it pretty good, understand that the matrix to the left is x, but this is perhaps x1, x2, x3, x4. So x is a matrix full of unknowns. So it has to have the same dimension as this right here. So x1 is equals to -7 over 2. X sub 2 is equals to 5. You know, or instead of x, it could have been a, b, c, d, lowercase, right? They're just variables. So keep that in mind. That'll help you be a better problem solver when it comes to matrices. Next, we've talked about adding and subtracting and scalar multiplication. But can we multiply matrices? Or like I talked to you about earlier, can we divide them? You know, like what's the deal? What's left? So matrix multiplication is very interesting, but it can be a little bit confusing. So we want to think of it as a row by column multiplication. Okay. So, for example, let's begin with a 2 by 2. You have matrix A be the matrix that has elements A, B, C, D. Matrix B has elements E, F, G, and H. So what's happening here is that you're going to multiply the first row of A by the first column of B. Okay? And the way this goes is that you do this times this plus this times this. So it's a little complicated, and it maybe just shows you better in a little example. But the idea is this, okay? So this comes from row 1, column 1. This down here is row 2, column 1. This element right here comes from row 1, column 2. And then the bottom element is row 2 of A, column 2 of B. Okay? So a better way to show you is here. For example, matrix A times matrix B. Right? They're being multiplied with each other. And it's not enough to just multiply A times E and move on. And it has to do with distributing and having to account for all the different combinations of things. Okay, so that's why we have to do this process like this. So A times E plus B times G. Okay, what happens if we have a larger matrix? So let's say that we have matrix P and Q here. This will be another example, and we're multiplying. Okay. And I leave those big spaces because it could be that we have more elements there, but all that we're doing is coming up with the first element of the product. So this would be AE plus BF plus CG plus DH. And this right here simplifies to a single number, right? So that right there becomes the first element, 1, 1, in the product of PQ. Okay? So let's go and do some examples where we kind of exercise that type of procedure. Okay, so given these two elements, these two matrices, which have dimensions 2 by 2, let's find their product. And we'll go the long way showing all the different sums and all of that. So first thing we'll do is this times this, right? So this becomes 2 times 0 plus 3 times 5, right? That is the first element. Then, I guess we can do it in different colors. We'll do some blue here. This times this for the element right below. So this becomes 4 times 0 plus 7 times 5. Then we'll do the first times the second column. So 2 times 1 plus 3 times 6. And then finally, the second row times the second column. And that becomes 4 times 1 plus 7 times 6. So let's simplify. 0 plus 15 is 15. Then we have 0 plus 35 is 35. Then we have 2 plus 18, that becomes 20. And then finally, 4 plus 42 becomes 46. Okay, so that is the solution between A times B, right? Matrix A times matrix B. Now, here is something else that we need to know about matrix multiplication. So, how can you determine how big your matrix is going to be after you multiply it? You're wondering, well, what kind of question is that? So, two things need to happen. Well, one thing needs to happen before you can actually perform the multiplication, okay? And it is that you have to compare their orders. So, for example, if I was looking for the product between matrix A and matrix B, I cannot go ahead and just start multiplying before checking to see if that product can actually be done. So here are the dimensions of A, here's the dimensions of B, right? The order of A and the order of B. This inner has to equal, right? This inner dimension has to be equal in both in order for the product to be carried out. If it's not equal, then you cannot multiply the two matrices, just like the way you cannot add two matrices that are different dimensions for the same reason. Now, what's up with these numbers outside? What about the dimensions, the outer dimensions? That's going to tell me the resulting order of the product. So whatever A times B is, if it can be done, is going to have an order of m by p, or the outer numbers, okay? Let's do an example and some kind of practice and just kind of talk about the order or the dimension of things. So matrix A has dimensions 2 by 3, B has dimensions 2 by 4, C has dimensions 3 by 2, D has dimensions 2 by 2. Can I do A times B? So what is A? A has dimensions 2 by 3, and I'm trying to multiply it with B, which has dimensions 2 by 4. And so all I have to do is look at this inner portion, is compare them. Are they the same? Obviously not. So I cannot. So no. What about A and C? Again, A has 2 by 3. C has 3 by 2. Alright, so I compare the two and I notice, hey, the inner dimensions are the same. So yes, I can carry out that product. Now on top of that, what is the resulting order? So the order of the product is going to be a 2 by 2 matrix because that's the numbers that are outside. Okay, so if you multiply a 2 by 3 times a 3 by 2, the resulting matrix is going to be a 2 by 2. Okay, can I do D times A? So D has dimensions 2 by 2, A has dimensions 2 by 3. Can I do the product? Can that be done? And the answer is yes. At least it has the inner dimensions matching. That's great. Yes, the product can be done. What is the dimensions, or what is the order of the resulting product? And it's going to be a 2 by 3 matrix. Can you do C times B, which is a 3 by 2, and you're multiplying it to B, which is a 2 by 4? And the answer is yes. The inner dimensions match. Good. What is the size or what is the order of the resulting product, and that is going to be 3 by 4. Okay, so hopefully that makes some sense as to how to figure out matrix products, like what can you actually multiply with another matrix and what you cannot. Okay, so can we do A times B, right? So I don't know, let's do it. So A has dimensions 1 by 3, right? 1 row, 3 columns, and I'm trying to multiply it times a 3 row by 1 column. So yes, I can do it. The resulting size is going to be a 1 by 1 matrix, meaning it's only going to have one element. That is great. Okay, so what's the real solution here? AB is equals to 1 times 4 plus 2 times 5 plus 3 times 6, right? It's the product between the corresponding elements and then the sum of all of that together. So 4 plus 10 is 14. 14 plus 18, I believe, is going to be something like 32. So 14 plus 18 AB is the matrix with one element, 32. Great. Can we do B times A? So B times A is going to be a matrix that is 3 by 1 times a matrix that is 1 by 3. And yes, it can be done. The resulting matrix is going to be a 3 by 3. Okay, so let's put them next to each other so that we can see what's going on. So 4, 5, 6 times a 1, 2, 3. Now, how is this going to happen? So remember, you do the first row, which is this, times the first column. So you get 4 times 1. The first row times the second column, so 4 times 2. The first row times the third column, so 4 times 3. And we move on, right? Then it goes 5 times 1, 5 times 2, 5 times 3, and then 6 times 1, 6 times 2, 6 times 3. Four, 8, 12, 5, 10, 15, 6, 12, 18. So notice how the order in which you multiply things gives you a different result here in matrix multiplication. So be careful with that, right? Don't think that A and B is the same thing as B times A, and you should be alright. That is everything for matrix operations.